I would like to welcome everyone to our EasyPower webinar on the Arc Flash Hazard Report. Today we will discuss the data that is shown in the Arc Flash Hazard Report. We'll also look at the Scenario Comparison Report, which includes similar data. As we proceed, if you have questions, you can let us know and we will try to answer them. If you have further questions, please contact technical support and we will try to address your question. The following two slides show the data that is available in the Arc Flash Hazard Report. The first slide shows the categories that are shown by default in the report. Other data that can be shown in the report is included in the second slide. So the default data includes the ARC fault bus name, the ARC fault bus KV, upstream trip device name, upstream trip device function, equipment type, ground, ARC gap, bus bolted fault, bus ARC fault, trip time, opening time, ARC time, estimated ARC flash boundary, working distance, incident energy, in comments or required class. The other options that are available from the default in the Arc Flash Hazard Report include the bus area, bus zone, location description, location X, location Y, floor, AC and DC, line to ground bus KV, upstream bus name, branch bolted fault KA, branch arcing fault KA, limited approach boundary, restricted approach boundary, prohibited approach boundary. The last three are the shock boundaries. The number of labels per bus that you would like to print, and a comment that's unique that can be entered for each bus. So though we've split the options up between the two slides, the user can modify the configuration to show the data in the report that you choose. So just because it's included in the default report doesn't mean it has to be included in the report itself. Now we'll look at the Arc Flash Hazard Report in EasyPower and go through each of these items in greater detail. So we have a system here. It's a fairly simple system, but it has a lot of different features that we can show what we're trying to accomplish here today. So we have a system here, a cogen system. We got a generator and we got a utility source that supplies the medium voltage bus, and then we have a double-ended substation that is connected by a normally open tiebreaker. Also included in the system are a number of MCCs and panels, and we also have a standby generator that's connected to the system through a ATS that serves this panel B3. So this is a good system to discuss the Arc Flash report and also the Scenario Comparison Report. Okay, so going into short circuit focus, I'm assuming that most of you are familiar with the short circuit focus. And we have basically the fault bus. This is how you follow the bus. We have different displays, and then we have some tools and some different edit and view options. So in order to fault a bus, we press the fault bus button. Right now I'm showing the half cycle momentary currents on the one line. If we zoom in a little bit, you can see those currents. They're also three-phase. In the short circuit options, I'm going to go to the arc flash hazard. To show the arc flash report, we need to check the arc flash spreadsheet, saying OK to that. Now if I fault all the buses again, even though I'm not showing the arc flash results on the one line, there is a, under the window, arc flash hazard report. So I'm going to select that window, and you'll notice here that we have the arc flash hazard report for the system. And right now we have selected the excluding all devices, or excluding main output. So we only have one result for each of the buses. So this screen here is a default output display for the report. Under the report config, you can choose many other options, and these are the ones that I mentioned earlier. So everything that we mentioned is here, just a matter of checking the box and moving through. So we'll mess with that a little bit more in a few minutes. But we'll start with the default categories as far as the display. So the first couple are straightforward. Arc fault bus name, that's just specifically the bus ID that you've given it in the data dialog. The bus KV is the KV of the bus. So those two are pretty straightforward. The third and fourth rows or columns, the upstream trip device name and the upstream trip function. The device name is the device that the program has determined to be the tripping device. It is not necessarily the next upstream device. So the column lists the protected device that is used to determine the duration of the arc flash hazard. In most cases, if your system's coordinated properly and you have selectivity, it's going to be the next upstream device. But if you do have some miscoordination, what we're looking for is the quickest clearing time for the arc flash, so that is the ID name that's presented. So one case would be if you have a main breaker on a switch gear, as in our case here, and you also have an upstream relay, you may have, depending on how those devices are set, this may trip prior to the main breaker tripping. So if that was the case, then this relay would be shown in the table. So going back to the arc flash report, you'll see that, and I'm going to, for the moment, show both the one line and the report. If you hit F8 on your keyboard, you can have both screens automatically size to your window, or both windows size to your screen, and it's just a little quicker way to see both at the same time. But you'll notice here, so for ATS, which is this device, breaker B3 is the trip device. where for the medium voltage bus, or let's look at switchgear A. R3 is the tripping device. So we have switchgear A, break or relay R3 is the trip device. In the upstream trip device function column, if the device is a relay, I'm going to slide this up a little bit, then it gives the function. So if in your relay you have multiple functions, it'll show the function that that was used to clear the or to trip for the arcing fault. The next column is the equipment type. And if you go into the bus dialog, so I'm going to go back out of database edit focus and out of short circuit focus, go into database focus. You'll notice I opened the bus dialog, so I double clicked on the bus. There's a type field in all buses that have a bunch of different selections. There's switchgear, open air, conductor, MCC, panel board, and then a bunch of different selections. So this is so that you can identify the kind of equipment that it is. This is important for the arc flash calculations on a couple different levels. When you have a arcing fault within an enclosed piece of equipment, so like a switchgear or a disconnect switch, an MCC bucket, the arc flash incident energy is typically higher than if it was an open air condition, because all the energy is directed through one area instead of in a 360-degree always exposure for that fault. So saying okay to that, we're going to go back into the short circuit focus, and I'm going to fault all the buses again. And I'm going to hit F8 to bring up the arc flash report. So you'll see in our equipment we have an ATS, three switchgear, some MCCs, and a couple panels. So MCCs and panels and ATSs are automatically given an equipment type. It's only in the bus that you actually select the type. Now, the arc gap goes with the equipment type. And the arc gap, some basic or some standard gaps are provided by the IEEE 1584 in the standard as far as what that gap is. And so so we've used those standard gaps in accordance with the equipment type. Those gaps are based on the type of equipment and the voltage level. And those gaps are given in or are provided in the library. So in the library, I pulled up the library. To access the library, you go under the E and open library. That pulls up the screen to open the library that you're pointing to. Actually, let me cancel that. Let me close this library and just show you, in case you're not familiar with that. So I would go here to open the library, and then this is the window that my library, or the folder that my library is in. I say open, and we're going to give it a second here. So this is an Access database, so any changes you make in the library are automatically stored and saved. So there's once you make a change, you can't go back and try to replace it unless you replace the data. So in the tree, we have a bunch of breakers and fuses and cable data, and this is where we enter all the information that's required that can be adjusted over time. So in the tree under the arc flash hazard, we have some defaults. So this is where we enter that data. So you'll notice that the equipment type, and there's a NEMA gap that goes with it. This is the number that's pulled out and used by the software that corresponds to that number. So for the switchgear, you'll notice that we had a gap of 32. For a panel board, we have 25, and so the MCC is also at 25. So so this is where that variable is that's used and where it can be found. You'll notice that each of these variables is for a specific system kV. And 0.2 and 1 kV, 1 and 5 kV, 5 and 15 kV. So as you get up to higher voltages, you'll notice that the gap goes up more. So for a switchgear at between 15 kV and 38 kV, it's 254 millimeters. And so as you go further up, then it becomes bigger and bigger. So I'm going to close that and go back to the one line and the report. So the equipment type basically gives the arc gap. So you'll notice that in the report that, or in that table, that like an ATS and a switchgear at the same voltage had the same gap, where the MCC and the panel had a different gap, but it was the same for both. So if you have a question, what type of equipment should I specify this as, understanding what that gap is, if you're debating between two different types of equipment, whether it's a panel or a panel board, well, it has the same gap, so it's going to give you the same arc flash incident energy. But if you're debating between like a panel board and a switchboard, those gaps are different. So you might take a little bit more time and try to figure out which one would I choose. In the 1584, there is a reference to ground. So this tells you whether the software has determined that that is a ground or a grounded circuit or not. In this case, all the results are grounded. The next two columns are the bus voltage fault and the bus arcing fault currents. These are specific to the bus. So for this demonstration, I'm just going to fault the switchgear A bus. and hit F8 to show a little bit more information. So you'll notice here I'm going to go to the Arc Flash options. You'll notice that the calculated Arc Flash is using momentary currents for the calculation. So on the one line, I've shown half-cycle three-phase currents. Arc Flash is using half-cycle three-phase currents based on the settings that I've specified. So you'll notice that this 40.812 is the bus current. So that will match. The and then the bus arcing fault current is calculated based on the IEEE 1584 equations. I guess that would be another thing to show here. You know, any of the Arc Flash options that you can specify are in these options. So the standard is IEEE 1584. So I'm referring to the 1584. There's a few other standards that are also available, but for the discussion on the Arc Flash spreadsheet report, we just want to stick to the 1584. The output type was excluding main, which I mentioned earlier, and momentary as well. We'll discuss this in a minute using first the worst case arcing current. Okay, so this is based on the 1584 equations. This is what is used to calculate the actual incident energy once you've determined what the trip time is. So this goes. So this is one of the major factors in determining what your incident energy is. The trip time, opening time, and arcing time all go together to make up your actual arcing time. Or, I'm sorry, the trip time and the opening time together make up your arcing time. So the trip time is the amount of time that it takes for the arcing. I'm sorry. The trip time is the amount of time it takes the protective device to trip based on the manufacturer's curve. So if it's a low voltage breaker, that trip time is actually the arcing time. But for a relay or some other device that's pointing to another device to actually open to clear the fault, in this case, we're looking at relay R3, and so it needs to open this breaker to clear the arcing fault. Therefore, we've added this breaker opening time. So if I fault all buses here again, you'll notice that some have a 0 while others have an opening time. So the breakers, and this is also for fuses, because there's no other device, it's 0, and it gives you an arcing time of 0.05, which is the same as the trip time, where for a relay, because you have the breaker opening time, that is included in the arc time. If you also, in the relay dialog, you can also have an auxiliary time. That's also been calculated in this, or added to this opening time. Before we go further, I'm going to add a couple things to my report here. So two of the other options that you can select are branch bolted fault current and branch arcing fault current. These are based on the tripping device. So for instance, I'm gonna fault switchgear bus A again. So we only have that data. And then I am going to click on remote VI to see what the remote currents are at the elsewhere in the system for the fault at the switchgear. You'll notice here that the current flowing through the relay R3, is 1.256 kiloamps. That's what's shown here as the branch bolted fault KA. We calculated the branch arcing fault as 0.531. And this current here is the current that's used to determine the trip time for the relay. So I'm going to record the 531 KA, and I am going to go to the coordination focus, and I'm going to select the relay down through the switchgear. I am not going to include the main because we're not looking at the main in this case. So I'm going to plot the TCC, and we'll try to make the window here as big as possible. And I'm going to fault the bus switchgear A1, or switchgear A. If I right-click on the relay, I know it's the tripping device, and say Insert Arcing Current, and then we'll zoom in a little bit more. Delete this tick mark. You'll notice that in this arcing tick mark, the current that's shown is 531 amps, which is the same number that was shown in the report. You'll also notice that if you take it up to the relay, and then I'm looking down here, I had to, as I pull off, down here in this area on the status bar, it shows the actual coordinates. So hitting Control, I get a cross arrow, and so at about 0.36 seconds, the relay will trip. So now closing this, go back to short circuit, pulling up the Arc Flash spreadsheet, the device trips in 0.355 seconds. So that was taken directly from that relay. So that's why we give you all these different numbers in the report, because these are all important to actually calculating what the incident energy is. The Arc Flash boundary for this case is 143 inches, and that, based on the equations, is the point basically that you don't have to be in PPE. So 143 inches from this switchgear is the distance that you will not incur the second degree burn. So and by definition, a second degree burn occurs at 1.2 calories per centimeter squared. So this is a back calculation to determine what the distance is to have an incident energy of 1.2 calories. Scrolling over a little bit, we have the working distance, 18 inches. Typically, that is the worst case. The NFPA has some other working distances as the voltage goes up. If you click on the plus, there are other working distances that are calculated, so you could use that to see as you're working through the table, you know, at 18 inches it's 25.5, but you can also, if you step back, you know, 18 inches, it drops to 9.2 calories. So there is some usefulness. And then the final category here is incident energy, calories per centimeter squared. So this is really, these last three numbers are the numbers that you're really looking for. You know, the incident or the, you know, the boundary as far as when you have to start wearing the equipment, what the working distance is for the particular incident energy. For the working distances in the short circuit options, you'll notice towards the bottom of the table that we have for a number of different KVs, there are working distances. These are the working distances that are used in the report. You'll notice that up here for working distances below apply to enclosed and open air, there are different sets based on whether it's an enclosed equipment and an open air equipment. So if you're working with open air and you change a default distance in the enclosed, you won't notice it won't be pushed through into the calculation. The other thing when it comes to working distance is the units. There are a number of different options for units that can be selected, including both US and metric units. So closing the Arc Flash dialog or options dialog. The comments right now is blank. This can be defined as a couple different with a different column name. The other name you might see it as is required clothing class, and that is based on, if I go into the options, the advanced tab goes on this PPE level. So we have two different tables that we reference. The NFPA 70E H.3b is from the 2012, and it applies the standard based on the 2012. In that standard, it basically states that if you use a calculation method to determine what the incident energy is, you should not use PPE level with that. They want to disassociate the two. The NFPA 70E is. The NFPA 70E 130.7 C16 is from the 2009 NFPA 70E, and back then there was a coordination between the PPE level and the calculation. So if you're using the 137C, I'll say OK. I got to change one other thing. Let's fault this. Then you'll see the PPE level, where if you're using the wrong button, let's go back to the options. I'm going to set it back to the 2012, and we won't show any PPE level. So that is the standard. and then we fault the bus again. Then we're back to comments. So previously it was required clothing class with a PPE level. So those are just for your reference. If we go back to the library, we have PPE levels as another column, and so we have the two different levels. So PPE level description. Here we're missing the PPE level, and this follows the table 8.3b. Okay, so closing or going back to the one line. So that's basically the most important data that we that you'll use in the report. If you look into the configuration, there's a bunch of other data that hasn't been checked. So I'm going to choose all columns here. And so this gives you all the columns that we can have in the report, and you can modify this as you wish. Most of these are just different cells that you can find within the dialog. So the first one here, area zone, so whatever number you have in there, you can show that. These have been added over time based on requests from users for labeling purposes mostly. The next few, location description, XY coordinates, and floor, are all under the location tab in the dialog. So if you enter some information in those would show up there. AC/DC, if it's an AC versus a DC fault, you can specify that. If you're looking at what the line to ground voltage is, you can also show that. Upstream bus name, that's the bus that your upstream device is off of. So in the case of R3, it's off of the MV bus. So those are each of these cells we've already talked about. If you want to show what the approach boundaries are, limited, restricted, prohibited, these are the shock boundary numbers. You can show those in the report. And then the last two comments really go with label printing. So these are actually interactive with the data dialog. So if I open this dialog, we'll go to the Arc Flash Hazard tab. You'll notice towards the bottom that we have a labeling area, labels to print. So if you're doing a batch printing and say you have a switchgear where you want 10 labels printed, you could specify 10, and then every time you printed, there'd be 10 labels for this device. You can also add a comment that's specific to that label. So for this switchgear A, maybe I want 5 labels, and I want this is we could say normal operation or something like that. You can put in whatever comment you want that's specific to this bus. So if let's see. So you'll notice now that the data that I've entered is in here. I can also, if I go back to the database edit, folks, I'm going to save the changes. If I go into the switchgear, I can also change it here, and we could say just whatever generic thing, I'll just leave it at normal this time. So this is just a demonstration that this will get stored. And so if so you'll see that information is stored in the dialog, and you can enter it both ways. So that takes care of all the different cells and gives you a description of what their use is for and why it's there. One thing as far as, and we're not going to go into detail with this, but I just want to make sure that you're aware of this. The Arc Flash spreadsheet is where you print your labels from. So with the Arc Flash spreadsheet active, you have a label button up here, and this is where you access the labels. So you can choose print labels for all devices. In this case, we only have one. If we had faulted all the buses, then and selected a couple, then you'd also get print labels for selected devices. And then you'd go into print labels and another screen will pop up. But that is where you print from. You can also, a couple other things, you can also export the report and open the report into Excel, and there's some print and that. Actually, there's one thing I forgot to mention is that in the Arc Flash report here, you'll notice that some of the text is black and some of the text is magenta. In the short circuit options, and I mentioned this earlier, the 1584 wants multiple calculations to be performed because the arcing fault is really unknown, and it's more of a, looked at from probability as far as what that is. So when the fault is 1,000 kV, less than 1,000 volts, the bus voltage, they want multiple cases to be considered. So there's an 1,000, so we're, by default, we look at 100% of the calculated arcing KA and 85% of the calculated arcing KA. In the program, the way we handle that is the difference in color here between the black and the magenta. If it's black, it's the worst case result is the 100%, and that's the data that's shown. If it's magenta, then it's 85%, and that's the worst case. So we calculate both cases, and then based on that we determine which is the worst case, and we present that. And so if it's the 100% result, the text is black. If it's the 85%, then it's magenta. If you were to print this report out, the way we handle that is you'll see an asterisk next to the ones that are 85, and there's a note on the printout as far as that. So that's how we handle within the software that case. The expand collapse, that just expands all of the cells for the different working distances, or collapses them all. That's the report within the short circuit focus. You can also, within coordination focus, you can also show the Arc Flash report. So as long as you show it in the short circuit, it'll show in coordination as well. So you don't have to go back to short circuit, even though I did that for the session today. For those of you that have Easy Solve that don't have the coordination focus, you'll always be accessing that in the short circuit focus. So that's the basis of what all the columns do, and what the information that you can gather from that. The reason that this is a little bit more complex of a system is to show the scenario manager and the scenario comparison report. So in this system, I'll say OK to continue. We built in 6 different scenarios, and they're simple changes. Basically, one scenario is using the cogen as the source. Another scenario is using the utility as the only source. Another scenario, and the base, which is the base case, is using both. We also have some other scenarios that have a closed tiebreaker, and then another scenario that's just for the standby generator. So a bunch of different scenarios. Very well could be similar to your facility in some way. But under the Create Scenario Comparison Report, you can so under, let's do that again in case I went too fast. Under Scenario Manager, Create Scenario Comparison Report. This is after you've created your scenarios and you want to compare the Arc Flash results for all the different scenarios to see what the worst case is. So we have Arc Flash results and scenario groups. So if we'll come back to this. I just want to show you the report first. And I'm going to say no. It says, do you want to save your changes? But it'll move through and create the report. So it calculates the Arc Flash instant energy for all the buses and all the reports by default by the settings. So you'll notice that most of the information that's provided is the same as the main Arc Flash report. There are a few differences. One is the scenario, so we label it by scenario, and then it also tells you what the worst case is. So if we look here on this bus ATS, these are all your different instant energies. This is the worst case. It happens, you can see it by the X, panel B3 on the standby generator. So when we're in that scenario, that's when you get the worst case. It's not always that case. You can see on the medium voltage bus, the worst case is in the base case. It looks like they're similar in other cases, but this is the one that was given. The switchgear A, the worst case occurs when the cogen only tie is closed. So if you have many different conditional configurations that your system can be set in, this is a good way to apply those. There are a few filters that you can use. One, which we have set up right now, is to show all. You can show just the worst case. So you have the bus name and then what the scenario is where it's the worst case. But this is much more similar to the report, the standard report. You can also filter just to show the worst case between a couple. If maybe you have a bunch of different conditions and you want to see what your worst case is, but maybe you only want to label on a couple of your scenarios because the others might happen once a year, once every 5 years, something. And so in those cases you would look more towards a work permit process than relying on the label itself. So if I said okay to that, everything's done just based on those devices, or I'm sorry, those scenarios. You can also print the label. You can print worst case for each scenario for all buses or the selected buses. You can also, excuse me, you can also open it in Excel if you want to do some other modifications to it, print it. Fairly straightforward. As far as the adjustment of what columns are shown, this has a little bit more restriction versus the main Arc Flash report in this case. But I'll show you what we can do at this point. When you bring up the scenario comparison report, you can add result groups, and this so these are all the different columns that you can show. And so if there's only a few that you want to see, maybe all you care about is the working distance, the incident energy, and the arc flash boundary. So you could add those. You could also do it for just a specific set of buses, but we'll just keep all the buses. So I could say store as, and set a group name, simple, say OK. Now you just choose which one you have. You can also only do a certain number of scenarios as far as the ones, so same kind of procedure. So maybe you just want to see what the difference is between, in our case, both the generator and the utility only, and the cogen only. And I'll just call this simple as well. Say OK, and then we can run this case, create report. We'll say yes to save the changes this time. And now it's a simplified report. So in that case, that's how you would specify which cells or which columns and which information you want to provide. But basically, the default information is what is the default data that's shown in the Arc Flash hazard spreadsheet is what's shown in here, or what's available in here at this point. So that is the Arc Flash spreadsheet and the scenario comparison report. We did talk about the scenario. Typically, this is the best way to deal with scenarios, but you can also within, I'm going to open a scenario. Let's do the utility only, tie open. So basically all we did was open this device. All the same functionality is available in, as far as, well, you need to go set the Arc Flash spreadsheet. We'll fault the buses again. So the same table is still there. It's just based on the scenario. So you can go through each scenario individually, or you can use the scenario comparison report to compare the results between all of the scenarios. That will wrap up the webinar for today. So I thank you for attending, and I hope you were able to learn some valuable information. Thank you, and goodbye.